We move on to the next question. That would be 53. 53 says cassette versus CD sales. Has the increasing popularity of the CD affected the sales of cassette tapes? And we're going to talk about that a little bit. Basically, I need a time plot, but it's a double time plot, which means that each year you're going to have two dots. You're going to have a dot for cassettes and a dot for CDs, and you need to go from 1990 to 1999, and then your y-axis should be how many sales you have in millions. It should go from 0 all the way up to 90, going by tens. And you just want to plot the dots for CD and cassette on each year, then connect all the CD dots and connect all the cassette dots, and see how that changes as you go through. Okay, that's number 53. Next, number 54. X bar and S are not enough. The mean and standard deviation are not a complete description of a distribution. The ones with different shapes can have the same mean and standard deviation. To demonstrate this fact, use your calculator to find X bar and S for the following data sets. Then make a stem plot of each and comment on it. So data set A, it wants you to actually put them in put A in list 1, get the mean and standard deviation. Then make a stem plot of just list A, of data set A. So basically, the stem plot for that, your stem would be like 8.1, and then your leaf would be 4. That would be 8.14. Your stem would be 8.2, and then your leaf. So it can be a little difficult on that. You can change it and make your stem. So I'll give you an easier one for 54. Let me scroll down. Let me find this one. So for 54, when you're doing the stems, you could just do 3, 4, 5, 6, 7, 8, 9, and they said you can round it to the nearest tenths place for your leaf. So 9.14 would be a 9, and then the leaf would be a 1. So they're going to let you round it on that to make it easier. But basically, you want to look at the mean and standard deviation, but then look at the stem plots and see if you can tell something from the stem plots that you couldn't from the mean and standard deviation. And again, remember, you don't have to do mean and standard deviation by hand in these, only the ones that I said to. All right. Next question, number 55. Says in each of the following settings, give the values of A and B for the linear transformation, then explain how the transformation will affect the mean, the IQR, the median, and the standard deviation. Mean and standard deviation, they move based on outliers. Median and IQR do not move based on outliers. So mean and standard deviation get pulled with outliers. Median and IQR do not get pulled with outliers. So that's really the key that you need to think about when you do these problems. Again, kind of use the back to help you, but think about that because it's going to be on the test. Number 58, as I skip through. 58 says, which measure of center, the mean or the median, should you use in each of the following situations? Remember, median. The first one says Middletown is considering imposing an income tax on citizens. The government wants to know the average income so it can estimate the total tax base. So it wants to know what the average income is, so would you use the mean or the median? And then in a study of the standard of living of typical families, a sociologist estimates the average family income. So again, think about whether you would use mean or median, and then tell why you would use the mean or the median and what that would show. And then the last question for tonight was 62. That goes into some of your review questions. 62 says, the Canadian province of Ontario carries out statistical studies of working of Canada's national healthcare system in the province. Bar graphs on figure 1.24 come from a study of admissions and discharges from community hospitals. They show the number of heart attack patients admitted and discharged on each day of the week during a 2-year period. And you want to explain why you expect the number of patients admitted with heart attacks to be roughly the same for all days of the week. Does the data show that's true? And then describe how the distribution of the day on which the patients are discharged differs from the day on which they are admitted. So what's different about when they're discharged and when they're admitted? And in A, why would you expect the number of patients admitted for heart attacks to be the same through all the days of the week? And that's on figure 1.24, which is right below. It's right here on page 67. So basically, I'm looking at discharges, and what I noticed right away is, why is Sunday so low on discharges? Why is Friday so high on discharges with heart attacks. So you need to really think about some things there, and I think you can come up with maybe an idea. There's not a wrong answer here, but there is some thinking that needs to be done. Alright, so that takes you through day 4's homework. I'll be back tomorrow with day 5 in the chapter 1 review. The test will be on Thursday, so whether we have school tomorrow or not, we'll still take the chapter 1 test on Thursday. I hope you've enjoyed this. I hope you're learning a little bit from it, and it's helping you with your homework. If you have any questions, you can still use Twitter, DLWeaver87, and I'll be glad to answer those. Thanks.